Now, as we do our first topic in Chapter 5, we're going to start to undo some of the multiplication we did earlier, and we will be doing the greatest common factor and introduction to factoring polynomials. And the objectives we're going to go through. Now, as you recall in that previous video, we talked about taking the element here, 3x, and then distributing it. 3x is a factor, and then the binomial is a factor, and we get a product. Well, keep in mind we can reverse that by taking a product and see if we can take a common factor out of this. Now, common factor is one thing, but greatest common factor is often what they will be looking for. And you want a technique for doing this. So the technique that we're going to suggest is if they say 36 and they say 60, we'll do one on one side and then do one on the other. And I'll use the whiteboard for this. We want to tease apart all of the factors and what we usually say are prime factors. Well, 2 is a prime number, and we'll go into 30. We'll go into 60 30 times. 2 goes into there 15. Now, the rule of 3 says if you add the digits up, it's 6. And if that addition is divisible by 3, then this is divisible by 3. And of course, some of these are common. You would know that. All right, now 36, it's even, so we can take out a 2, and that's 18. That's still even. Take out a 2, and that gives you a 9, and 9 is divisible by 3. Now, what we want to find out of this is what are common factors. Well, this one has a 2. This one has a 2. There's another 2. There's another 2. Now there's a 3, and there's a 3. So if you then multiply these together, 2 times 2 is 4, times 3 is 12. The greatest common factor we can take out of 60 and out of 36 is 12. And that's the protocol for getting it. And that's what they're describing here. And hopefully you've taken these notes down. So here they're describing the protocol for finding the greatest common factor in a set of terms. Which factors are common to each term, and that altogether would make the greatest common factor using the protocol we just went over. All right, let's go on. Now we're getting to example 1, and write this up in your notes, of course, and we're going to see how it works. Now, sometimes we can eyeball what is there, and we don't need to do all that teasing apart. So, as I look at this, I know I can take a 5 out of each one. Can I take a 10 out of each one? No. But if I add these digits, I can 3, 9, 12. I know I can take a 3 out also. So 3 times 5 is 15. 15 looks like a good candidate for what you can take out of each one of these. And that's what they're saying. Now, for this one in letter B, and again, you've written this down, and now you're writing this down. We have a 20, a 15, and a 10. Well, again, the obvious one that you can take out of each numerical part here is 5. Now, if this was just 10 and 20, you could take out a 10, but 10 doesn't come out of 15. Now, the next thing we do is look at the letters. This is x to the fourth, x to the third, x to the fifth. Now, which power of x can you take out of each term? Think about it. And if you said x to the third, you're correct. You've got to take out the greatest common factor. Now we have a y there, and a y squared. So the greatest power of y that you can take out of each one is y to the first. And as we look at the answer provided, we see we did it correctly, following the suggested protocol. Now, continuing with background, but take some notes on this. Here we have a binomial. Now, the protocol would be put this part in parentheses, and then you're going to try to take something out of each term, and you can put a plus in there to help you along. And I don't know if you can see it, but you can take a 3 out of each of these. This will then become an n, and out of this is a 5. And that's what they're showing. Now, we did these in an earlier lesson already. 5 will go into 35 7 times. And as we bring the exponent up and subtract it, crosses that division bar, the sign of the exponent changes, and this becomes x to the sixth. Okay. And there that one is. And I believe we are up to date. And down below they gave us this other example. So -8 goes into 16, -2. And then subtracting 1 from the 5, we get a to the fourth. Okay, there's one other little modification we have to do below. And we'll use the whiteboard for it so you can see it a little bit better. Now, the protocol for doing something like this, you have a trinomial divided by a monomial, is to write it this way: 8x to the third minus 14x squared plus 10x. Now you're going to put each of the terms of the numerator over your common denominator. And students sometimes forget this protocol, but this is the way to do it. Now you simplify each of these, and 2 goes into there, 4, subtract 1. Here the sign will be -7, subtract 1. Here it's going to be plus, 2 goes into there 5 times, and this is x to the 0, which is 1. Or anything divided by itself is 1. So there's the answer. But again, this is the way to do it. You have a trinomial divided by a monomial. You write it again and then put the common denominator under each and then simplify. All right, let's go back to our regular board there. And then we'll continue. Now, for example 2, write that down. We'll go to our whiteboard to work them out. And notice what I've done is I've placed that common denominator under each of the terms. So what do I get this to simplify to? Keeping in mind there's a 1 up there. So this is going to be x to the second. I can take that, but I'm still going to be left with a 3 in the denominator. Here I'm going to have a -2x. And here, the only thing that cancels out would be the x's to become a 1. And we end up with something like that. So we've simplified this. And again, part B, I put the common denominator under each one. 5 will go in the 15 3 times, y to the second. Now there's a negative. 5 goes in the 20 4 times. 2 subtracted from 3 leaves me just y to the first. Now this is interesting. Notice 5 over 5 is 1, and y to the second over y to the second is 1. So 1 times 1 is 1. Sometimes students think, well, this will cancel out and become nothing. No, anything divided by itself is 1. Okay, let's go back and check this out. And we see it worked out there. All right, let's go on here. Now, we did take a look at what is the greatest common factor. We're now thinking of, if we have a trinomial, what's the greatest common factor we can take out of each one and then have the remains over here on the side? So to simplify this, we can take a 5y out of each of these terms, and then this is what's left in the parenthesis, that if we wanted to check, we would distribute again to get this product. Now, you don't have to take notes on this because we'll be doing some problems on this, and we don't want to make these too long. So this will be example 3, an A, B, and C part. So label it as that, and we'll go to the whiteboard to work them out. Now again, pause for a moment after you write it down and study it and see, well, what am I going to do? Well, here it's obvious. What's my common factor? And I'm setting up a protocol to fit it in. I can see I take a 6 out of both. Here I'm left with an n, and here I'm left with a 5. And if I distribute, I get back to the original. And for b, what can I take out of each term? Well, I can take an x out. This gives me an x squared. And then here you have to remember there's going to be a 1 there now, because there was a 1 in front of that we didn't write. So the point being, when you distribute, you have to get back to what you had originally. And for this one, studying it for a moment, we can take a 5 now out of each one for the number part. Let's go back to the whiteboard. And for the x's, we can take an x squared out of each one. And what are we left with? Well, here we're just left with an x. And here we're just left with a negative 3. So again, if you distribute, you get back to the original. And we see, if we go down below here a little bit, we have the answers. All right. Now, as we look at example 4, you're going to write this down. Again, we look at it carefully and see there's no x on this term, and this one's not divisible by 2. So there are no common factors. Now, they're saying this is the solution, but I'm suggesting 2. You could put a parenthesis around there and just put a 1 outside. You can factor a 1 out of anything. Now, a modification of this is, suppose we factor a negative 1 out of something. And they're going to show us this a little later. What does that do? Well, that changes all of the signs inside the parenthesis. So this now becomes a negative 2x to the 4th, a positive 3x squared, and a negative 2. Sometimes that's a useful tool in mathematics, that we take a negative out of something to reverse all the signs. A good tool for our toolbox. Now, for example 5, they're asking us to, again, factor out the greatest common factor Here's our trinomial, and I've rewritten it. We'll go to the whiteboard. And now they're going to show us two ways. First, I'm going to show you factoring out a negative value of something that will reverse all the signs. But what number can we take out of each one? Well, it's obvious, a 2. So I'm going to factor out a negative 2 from each one. And for the letters, I have a to the 5th, a to the 3rd, a to the 2nd. So the largest I can take out of each one is a to the 2nd. But now what happens here? Where this was a negative, it's now going to become a positive 2, a to the 3rd. Where this was a positive, it's now going to become a negative a. And where this was a negative, it's going to become a positive. And 2 will go into there 3 times. Now, if I had factored out a positive 2 from each one, then this would be a positive 2. This would be a negative. This would be a positive. This would be a negative. So let's check it out as we look at this, and you see it here. Now they've done both. They factored out a positive and they factored out the negative. We don't have to do both here. Now, to save a little time, we'll use some of what's in the book here as well. But this is example, let's see, what example is this? 6. And A is, what are we going to factor out of this? Well, we can factor out a 4 from each term. We could factor out an A from each term. And the greatest power of x that we could factor out is just a single x. And then we're going to be left with what's in here. Now for B, as we look at it, there'll be a negative in the middle. We have a 3 and a 6, so we know we can take a 3 out. We have x squared and an x, so the largest is an x. And y to the 2nd, y to the 2nd, we can take all of that out of there. And then whatever's left. Now for this one, again, we can take out a negative or a positive. Let's take the negative out of this one. A negative 14, 7, and 21. I think we could take a negative 7 out of each one. And we have a b to the first, a b, a b. So we can take a b out of each one. Y to the 3rd, y to the 2nd, we can take a y out. But since we've taken out a negative, this first term here will become a positive. This one will become a positive. And this last term will become a negative. Now for D, we have a 13, a 3, a 4. There are no common numbers. We have a to the 4th, a to the 2nd, a to the 6th. So we can take out a to the 2nd out of each term. B to the 5th, b to the 9th, b to the 3rd. We can take out b to the 3rd. And then whatever's left, this will be a negative, this will be a negative, and this will be a negative. Okay, now what you can do on your own is try to see what would come here. And then after you paused it, you can check your answers down below. There is A, there is B, there is C, and there is D. Trying to keep these a tad short if I can, but not too short or not too long. Now write this down for background. A binomial y plus 2, binomial x plus 4. We had said in an earlier section that we could multiply these, of course, by FOIL, but there's another way to multiply them. We could take this first term and multiply it by this, and we would get y times x plus 4, and then we would take our plus 2 and multiply it by this next binomial again. And lo and behold, that's the problem they're asking here. But now they want us to factor by grouping. So keep in mind that this is the factored form. We want to get this to become this now. Well, what do? Well, here's our common factor, which is x plus 4. So what do we do with the 2 and the y? Well, we put that in another parenthesis. Y plus 2. So again, something easy, if you remember what we're doing. Now, the key is they're going to say factor by grouping. Now, we're going to build on this a little bit. Now, for example 7, again, write that down, and then copy this down. We're going to factor by grouping. Again, a technique would be you have a common binomial. You could put that here, 5x plus 1. And then this term goes in this parenthesis, 3x squared. And this term goes there. And the same thing here. We'll just write it. 2 sets of parentheses. The 7a plus. Now, what's out in front of this parenthesis, even though it doesn't appear? There's a 1 there. So 1 there. And then our common binomial factor goes here, 2x minus 3. Now, you could put the 2x minus 3 first and this second. That's how often the book does it, but I like it this way. Okay, let's go on. Now, this is example number 8. And it's 4 terms, and the instructions were factor by grouping. So notice there's no common factor in all terms, but if we kind of separate these first 2 and separate the second 2, is there something we could factor out of these 2? And the answer is yes, I could factor out an x. And now I get y plus 5. Now, what can I factor out of these 2? Well, I could factor out a 3, and now I get y plus 5. So we have what we were working with before. In one parenthesis, you're going to put this and this, x plus 3. And then in the other parenthesis, you put y plus 5. And you have factored a 4-term polynomial by grouping. Now, in some of the problems you're going to get, you may have to rearrange things, but again, that's a skill you'll be working on. And we see the answer down below. Now, this is example number 9, and we're going to factor by grouping. There's 4 terms. There's no common factor among all of them. We're going to kind of break it into 2 parts. And what can I take out of these first 2? If you said an x, that is correct. You get x minus y. Now, if possible, you want to get an x minus y out of these 2 terms. So you have a similar binomial. But the signs seem to be opposite. Going into our toolkit, we're going to factor out a negative 5. And what does that do to each of these signs? It reverses them. But remember, if you multiplied through, you get this. So now in one parenthesis, x minus 5, this, and then in the other parenthesis, x minus y, and we have done it. And there it is, down below. Now, for example 10, they do give us another example. You might write this out, example 10, factor by grouping, and when you try it, you realize you don't have any that would factor. So you say, therefore, this statement is not factorable. Okay, we're running at 25 minutes, so we want to wind this up. There were a few more examples, but again, I think we have enough. We'll be doing our practice and our certify. Now notice, mastery for this certify, they've lowered it somewhat. It's at 75%. So you could miss a few and still get full credit. But again, when you do your test, you want to try for the best score possible.